Example number 4. A piecewise defined function f is defined as f of x equal negative 2x plus 1 for x between negative 3 and 1, f of x equal 2 if x equal 1, and f of x equal x squared if x greater than 1. I am going to make the 3 colors so that we will follow it easier. So I'm gonna do the yellow, green, and pink. For the yellow piece, the domain is between negative 3 and 1. For the green, the domain is just x equal to 1, so the domain is just 1 point. And the domain for the pink piece is x greater than 1. In part A, we want to find f of negative 2. So we look at the input. Negative 2 is in the yellow domain because negative 2 is between negative 3 and 1. So we will plug in the yellow piece. So we have negative 2 times negative 2 plus 1. And we got the answer is positive 5. F of 1. So 1 is in the second domain. So the answer is 2. And f of 2, 2 is greater than 1. So it's in the last piece, so we got 2 squared, and 2 squared is 4. Problem B. Find the domain of the function f. The domain for the first piece is from negative 3 to 1 union 1. This is the second piece, and the last piece is from 1 to infinity. So we combine all of this. If you draw the number line, you will see it's easier. So this is from negative 3 to 1, negative 3 to 1, and then the second piece is 1, and then the last one is from 1 to infinity. So the domain is this from negative 3 to infinity. So we combine the the domain of the 3 pieces. Problem C. Locate any intercepts. So to find the y-intercept, we will let x equal to 0. So we find f of 0. When we input the 0 into the function, the 0 is in the first piece because 0 is between negative 3 to 0 to 1. Sorry, to negative 3 to 1. So we will plug in the yellow piece. So negative 3 times 0 plus 1, and we got 1. The x-intercept, so f of x equal to 0, which is y equal to 0. That is f of x equal to 0. So this is the same thing as y equal to 0. So we look at the 3 pieces. We're gonna set each piece is equal to 0. So you can see that the middle piece doesn't work because 2 equal to 0. This is the false statement. We're gonna solve for the first one. We will minus 1 first, and we divide both sides by 2, so we get 1/2. And the last one we got x equal to 0. So the answer for the x-intercept is 1/2, 0, and 0, 0. So the x-intercept and the y-intercept is 0, 1. So is the y-intercept. Problem D, we want to wrap the function f. Let's copy the function f one more time. Negative 2x plus 1 if x between negative 3 and 1. So this is the first piece, so I will just work on this one first, okay? You notice that for the first piece, this is the line, and the x we will make 2 points for the line. We be smart, we're gonna make the x for the endpoint, okay? So for this one, the table, we will make x comma f of x equal negative 2x plus 1. We will make negative 3 and 1. When we plug in negative 3 into the function, we will get 6 plus 1 is 7. Negative 2 times 1 plus 1 is negative 1. So this point, negative 3, 7 and 1, negative 1. Because you see that at negative 3, it has the equal sign. So the negative 3, 7 will be close point. And at 1, it does not have the equal sign. So this point will be open. You can make more points in the between. For example, you can make 0, but we already calculate 0 in part A, f of 0. Now let's go back and copy f of 0 somewhere in part C. So we can see that if you pick 0, then the y will be 1. So you can plug in the point 0, 1. Now we have 3 points. Let's go ahead and plug them in. We have negative 3, 7. And 1, negative 1. It will be open. So we will connect these 2 points, and the point 0, 1 is here. So I'm gonna use the yellow line to connect this. Okay. So one more time, we notice that this point will be open, and this point is a closed point. Now we move on to the second piece. The second piece, we have f of x equal to 2 if x equal to 1. The domain is just 1 point. So if x equal to 1, you plug in 1 into the function f of x equal to 2, then you will get the answer is 2. So I'm going to use the green color for this. You have just 1 point, 1, 2. That is for the second piece. Now the last one, I will use the pink color. So x squared if x greater than 1. So I use the pink color for that. So we make the table, and you notice that the last piece is the parabola. For the parabola, we will make negative 2, negative 1, 0, 1, and 2 as we normally do. However, we look at the domain. The domain have to be greater than 1. So you cannot make this number. It's going to be 2. And of course, we will make 1 also. And at 1 will be open. So 1 square is 1, 2 square is 4. And if you can, you make 3. 3 square is 9. Okay, starting from 1. So you get 1, 1, and that will be open because at 1 you do not have the equal sign. Okay. And then 2, 4. And then 3, 9. And then you connect this, and then you can draw the arrow because it's continuous. I go back to the yellow line because this is a line, and sorry, this is not a line, this is a segment, so that's why we stop here. We do not have the arrow, any arrow for the yellow line. Look at this, it is a segment, n at -3 and 1. The last part E, we want to find the range. We look at the graph to find the range. You look at the maximum and minimum point for the y, so you can see that the y, lowest y is 1, -1 right here, and it's go up until infinity. So from -1 to positive infinity. And at -1, because it's open circle right here, so we use the open parenthesis.